Kia ora everyone, welcome to the next in the series of mini lectures. And what I'm going to do in today's mini lecture is continue to talk about endophytes and the benefits they provide to their hosts, but we're going to change gears a bit and we're going to use this as an opportunity to think again about things like experimental designs, controls, and interpretation of scientific data. So this goes back to some of the ideas I talked about in the mycorrhizal section where we looked at ways to think about experimental design, controls, and interpreting data. And now we're going to do much the same thing, but in the context of understanding the benefits that fungal endophytes provide to their host plant. And in particular, I'm going to focus on the potential benefit that endophytes provide to their host plant in terms of protecting them against fungal pathogens. So let's get started. I'll turn my video off as usual, and then we'll go through the slides. Okay, so as I said, what we're going to look at is the idea that endophytes protect plants from other fungal pathogens. And this has been generally proposed as a feature of endophytes, not just the class 1 endophytes that we're mostly going to focus on, but generally for other classes of endophytes as well. So a kind of general advantage that plants receive from having endophytes. And it's thought that the endophytes provide this benefit of protecting against other fungal pathogens from a variety of possible mechanisms. So for example, it could be that the endophyte actually feeds on the fungus. So if there's a fungal pathogen that invades a plant and there's an endophyte already in there, that endophyte will attack the fungal pathogen, eat it, and prevent it from infecting the plant. Another mechanism is that the endophyte might produce secondary metabolites that we've looked at in the previous mini lecture. And these secondary metabolites might be ones that inhibit that fungal pathogen. And then the final one is the idea of competitive exclusion. And so here the idea is simply that the endophyte is already inside the plant, and so it's already occupying that niche, and therefore the niche is not free for the fungal pathogen to come and then invade. And so it's like, well, I'm already in the house, you can't come in, so you're just blocking the fungal pathogen from coming in that way, in that kind of indirect way. So, as I said, many types of endophytes have been proposed to provide this kind of protection, but if we're scientists, we want to look at the evidence and see whether there is actually a case for them playing this role. And so what I'm going to do in this mini lecture is just start by taking a kind of a toy or a pretend example and going through some of the logic of design and interpretation. And then in the subsequent mini lectures, I'll look at some real examples. So let's get started and move on to slide number 2. And so here, imagine that you want to construct an experiment to test whether an endophyte gives resistance to a fungal pathogen or not. And so you come up with an experimental design, and the experimental design looks something like this. So you have plants where the endophyte is present and plants where the endophyte is absent, and you've exposed those plants to a pathogen that's called D. And then what you've measured, so the results are shown here in this graph, and what you've measured is the plant death rate, so the percent of plants that die over a certain period where they've been infected with the pathogen. And what you find is that when the endophytes, when there's no endophyte in the plants, there's a higher rate of plant death than when the endophyte is in the plant. So what I want you to do, I'm going to, again, give you a bit of an exercise to do here. So this would have been a class discussion, but you'll just have to do it by yourselves. And what I want you to do is I want you to think about what these results show. And in particular, I want you to answer the question of, do these results show that the endophyte is protective against the fungal pathogen? And why do you come up with that answer? And when you're thinking about this, you might want to think about what's being measured in terms of the response, plant death percent here, and try not to think about the motivation that I gave you for setting up this experiment. So instead of thinking about why this experiment was done or what you were trying to achieve, instead just look very objectively at the results that were presented. So what's being done, what are the results, and what can you tell and what can't you tell from these results. So I'm going to give you a couple of minutes to think about that, and then we'll come back and discuss that. So work on that by yourself. If you're not done in a couple of minutes, feel free to pause the video, obviously, to take a bit more time. Okay, so how did you go? What did you conclude? And I guess unsurprisingly, given that I've asked the question, the answer is no, you can't conclude that the endophyte is protective against the fungal pathogen. But so why do I say that? And the reason that you might have been able to figure out is that you're measuring the plant death response, but you don't know what that plant death is being caused by. So, of course, it might be being caused by the pathogen, but as scientists, we can't just simply assume that without testing it directly. And so it might be that this improvement from having the endophyte present, so definitely the endophyte seems to improve plant death, but that plant death might be nothing to do with the fungal pathogen at all. It might just be a general improvement that the endophyte makes. Maybe the plants die at a high rate without the endophyte for completely different reasons. Okay, so if I go to the next slide, what I'm asking in the next slide is, let's say that we want to determine whether it's resistance to the fungal pathogen that's causing this response. If so, what additional controls are necessary for you to perform in this experiment? And when you think about those controls, you should also be able to explain why. So what is the logic behind why these additional controls are necessary? So again, I'm going to give you 2 minutes to think about that, and then we'll come back and discuss that. Okay, so what controls did you come up with? And so the controls that you should have come up with are that you need to do the same experiment growing plants with and without the endophyte, but in no pathogen conditions. And the reason for that is that will tell you whether the endophyte has a protective effect for plant death independent of the fungal pathogen. So once you've established whether or not the endophyte protects against plant death without the pathogen present, you can then compare to the results where the pathogen is present and see if the magnitude of protection is greater with the pathogen present than when it's absent. And if so, then that would be evidence that that the endophyte is protective for plant death, specifically because of because it's protecting against the fungal pathogen. So if we go to the next slide, this is just summarizing the points that I've said in yellow here. So the data only show that the endophyte provides protection against plant death. It doesn't tell you that it's necessarily anything to do with the fungal pathogen. And if you want to show that it's a protection against the fungal pathogen that provides the improved plant death response, then it's necessary to grow the plants with and without endophyte in non-pathogen conditions. And in that way, you can tell whether the endophyte has a general protective effect on plant death for its host. And then if the protective effect that you observe with the fungal pathogen is greater than that, then that can lead you to conclude that, that the endophyte, in fact, does have a specific role for protecting the plant from plant death against the fungal pathogen. So hopefully that's clear. If it's not, go back and have a look at it again and think about these issues, because these are really important logical steps that you need to take to be able to interpret scientific data, not just for endophytes, but these general principles apply across all biological experimental interpretation. So make sure this is clear in your head and you can answer questions on this. And then, as I say, in the next mini lectures, we're going to come back and look at some real examples of these kinds of data and try and interpret those. But for the meantime, I'll sign off. And again, if you have any questions, please post them on Piazza.